Hello everyone and welcome to another episode of Kelly Telly. Today we're going to be talking about nuclear reactions, which is unit 2.4 in your textbook. Now nuclear reactions, the first thing you might think of is the nuclear bombs, or you might think of nuclear reactors, such as the one I've got in this picture here. Now nuclear reactors provide energy using nuclear reactions. So hopefully by the end of this video you'll have a little bit more of an understanding about nuclear reactions. Let's have a look. So nuclear reactions are a little bit different to all the other reactions we've looked at so far this term. The ones we've looked at so far this term involve the change of the amount of electrons in an atom. So when two atoms react, they either gain or lose an electron, in which case it's called an ionic reaction, an ionic bond. And if two electrons are shared, then we call it a covalent bond. Now, with nuclear reactions, the name probably gives it away, but they all involve reactions not involving the electrons, but involving the nucleus of an atom. So the nucleus of the atom is the part in the middle that contains all of the protons and neutrons, as you guys already know. Now, an actual nuclear reaction, as I said, involves the nucleus changing, usually the neutrons specifically, but sometimes the protons as well. So let's have a look here, the definition. Nuclear reactions are chemical reactions which result in a change in the nucleus of an atom. So at the end of a nuclear reaction, the nucleus of an atom will be changed. And if you'll recall the atomic number, which is the number of protons, if that's changed, it'll end up in a totally different element. So let's have a little bit more of a look at nuclear reactions here. So to really understand nuclear reactions, we're first going to have to look at radioactivity and what that means. So let's have a little look here. So when an atom is formed, depending on how big it is and a few other factors, it could be unstable. Those atoms that are unstable, they want to try and get stable as quick as possible. The same as every molecule in the world. Now, for it to become stable, it's going to need to change how many of its protons or neutrons are in the nucleus in some way. So it's going to either release some form of particle or some form of energy to try and get that mass here, the nucleus, to be stable. So this is the nucleus of the atom, to try and get that to be stable. Okay, so just to rephrase that again to make sure you understand, we have an atom here and its nucleus, there's too many particles in its nucleus, so too many protons and too many neutrons. Okay, so it needs to try and get to a stable number. So what it does is it actually gets rid of some of the either some energy or some of the particles itself, like for example a proton, to try and get to a arrangement that is stable. We call the rearrangement, so either getting rid of particles or adding more, whatever it is, usually getting rid of, we call it nuclear decay. So it's decaying and it's losing these particles and this energy. Okay. Now the nuclear decay releases an energy, or sometimes a particle. We call both of these radiation. Okay. So this is the main thing I want you to understand when it comes to radioactivity. So if something is radioactive, it goes through this process of radiation. Okay, so it goes through this process of nuclear decay. So let's look at uranium as an example here. So uranium is an element on the periodic table, and it is what most people think of when they think of an element that is radioactive. Now, it's a little bit, obviously this is a very confusing diagram we have here, but this is the Bohr planetary model of a uranium atom. Now, looking at it, you can see it's got protons, it's got neutrons and electrons. The red ones are the protons, the blue ones are the neutrons, and the green ones are the electrons. So just ignoring all the green ones for the moment, the electrons, let's just look at the protons and the neutrons. Now, compared to our atoms like carbon and oxygen, which have only a small amount of protons and neutrons in the nucleus compared to uranium, uranium has an extremely large number, has 238 neutrons and 93 protons in the nucleus. Now, this amount of this amount of particles can be stable, but for the most part, it does want to try and become more stable. And in doing that, it releases either energy or particles, and we call those energy or particles radiation. So that radiation is what humans use, if we go back, in the nuclear reactors to form energy. So uranium, we put uranium in here. Uranium goes in here, and as it just slowly decays, we don't even have to do anything except keep it from, exploding. We don't have to do anything. It just slowly releases energy, and we use that energy to power some of our machines and stuff. Okay, so that's this is just a basics here of radiation. I hope you understood this part, that a radioactive atom, goes through what we call nuclear decay, in which its nucleus decays and we lose particles and we lose energy. Now that particles and energy is called radiation. And in uranium, that amount of energy and particles it gives off is a lot. It's enough for us to use to power our machines and things like that. So I hope this helped you to understand a little bit more about nuclear reactions, and I'll see you guys in the next video.